In this video, I'm going to walk you through the steps to conduct an independent sample t-test that is comprehensive enough for you to actually write a thesis, a report, a manuscript. You'll certainly get enough information from here. And this is pretty much the steps I would follow in order to conduct an independent sample t-test that I'm interested in potentially publishing. So, first step is you want to make sure that your dependent variable is scored continuously, because that's one of the assumptions of the independent sample t-test, and you should check that first. So that means that the dependent variable is measured on an interval ratio scale or an ordinal scale with at least 5 points, like a Likert scale. Now I know that second part, the ordinal scale, is a little bit controversial, but I do provide evidence in the textbook that the t-test tends to work. It tends to give an accurate p-value when there are at least 5 points in an ordinal scale. So I also include in this step that we assume that there are only two groups that you're testing. That's the independent variable. So I'm assuming that you know that independent variable can only handle two groups, males and females, for example, in the independent sample t-test. So dependent variable checked and independent variable checked, levels of measurement. Normally distributed, step 2. Are the data associated with skew and kurtosis less than absolute values of 2 and 9? This is the rule that I keep repeating in the textbook, because simulation research supports the idea that the independent sample t-test, and other statistics for that matter, yield valid p-values so long as the data are less skewed than 2.0 and less kurtotic than 9.0, and these are absolute values. So if you do satisfy this assumption that the data are sufficiently normally distributed, they're probably not going to be perfectly normally distributed, but sufficiently normally distributed, you can use the regular t-test, the one that more technically is called the asymptotic normal distribution theory t-test, the one that you get automatically in SPSS. If you do not satisfy the assumption that the data are sufficiently normally distributed, because your skew and kurtosis exceed 2 and or 9 respectively, you have the option of using bootstrapping, which doesn't assume any level of normality. So, no big deal. Just go straight to the bootstrapping, assuming you have that module or access to a program that will do it. There are options out there. The next step would be homogeneity of variance. So you can use Levine's test of homogeneity of variance, which is a well-respected test in this regard, and it's done automatically in SPSS when you do the independent sample t-test. If you do violate the assumption of homogeneity of variance as tested by Levine's test, you can use Welch's t-test as a substitute, because the Welch's t-test doesn't assume any level of homogeneity of variance, and it doesn't assume equal sample sizes either. So you can use Welch's t-test if you do not satisfy the homogeneity of variance assumption. So once I've satisfied the assumption, I can then turn to the actual t-test and examine the result, the p-value, for example, and the t-value. Now, if it's statistically significant, or even if it's not statistically significant, I would follow on and calculate an effect size estimate, which would be either Cohen's d or Hedges g. Now, technically, Hedges g is more accurate, because it is a more accurate representation of a population effect, but so many people calculate Cohen's d for the independent sample t-test, and the difference between Cohen's d and Hedges g is really very small. Unless you have less than a sample size of 10 in each group, it's a very small difference. So it's up to you. Technically, you should call it Hedges g, and you should be calculating Hedges g. Step 6, you should probably graph your results in a bar graph with 95% confidence intervals on the means. That is probably the last thing you would consider doing. It's not always necessary by any means. It depends on the importance of the analysis, I would say. So not everyone would calculate a bar graph for their analysis, because they might run something like 5, 6, 7, 8 different t-tests. You could report a bar graph for each one, but it might be a little bit over the top to do so, so you'll have to take that in consideration. So those are the key foundational steps that you should consider following when conducting an independent sample t-test and trying to address a hypothesis related to the difference between two independent means.